Well, good day, guys. Today, continuing in my series of learning how to be a software developer, we'll be looking at writing another application. Last time we basically just did the Hello World application, a .NET Core command line app. Didn't really go into anything other than just creating the application and running it. And this time we're going to go a little bit further into actually developing something. All right, so starting from fresh, okay, Visual Studio is not open, so we go to the start button and we type in visual so that we can find Visual Studio. All right, and what I'm going to do this time is I start it up and I'm going to add it to the toolbar at the bottom here, so you don't always have to go to the menu, but we'll let it start first and then we'll just add it that way. Okay, so here it goes, and so I go to the bottom here and I right mouse click on Visual Studio, and okay, and I say pin to taskbar. All right, now it'll always be there. Now I don't have to keep going through the menu to get to it. Okay, so you'll notice that Visual Studio has opened up, and this is our application that we did last time. So you can either come and create a new project or just continue with the previous one. We're going to continue with the previous one for now. There's a few things I want to show you. So I click on that and it'll open that up, and should still have my nice big font. All right, and there we have our program from last time, still zoomed in and everything. Okay, so the first thing I want to cover today is indentation. Code line indentation. Most programming languages, well, if not all programming languages, modern programming languages uses the concept of indentation. It makes your code far easier to read. So what I mean by indentation is, well, firstly, you could write your entire program on one line, okay, in certain languages, such as C++, C#, etc. I'll give you an example of what it'll look like. So I can change this whole thing to one line. Okay, so there we have the entire program, Hello World program in one line of code. All right, and it's a very simple program, so you can actually make quite simple you can easily understand what it's going to do by looking through that code, but you can't just immediately see it. You've got to go through it and actually start looking. Now, for big programs, this is completely unusable. No one can read your code. Putting things in one line makes no difference in how fast it is to, to run or anything like that. When it executes, it makes absolutely no difference. And to show you that this will work is, I'll press F5 and run it. And according to C#, it's going to be the exact same as the previous program. So it's trying to run. All right, and there it is, and it shows us Hello World, and so it works. It doesn't have to be. It can be all in one line. But there's a term called being idiomatic in your programming language. So there's what it comes down to is that there's a standard how people that uses your particular programming language actually codes. Some people believe, or some programming languages require you to name your variables using snake case, whereas like C# is Pascal case and Camel case, not snake case. It's idiomatic. It's just for that particular language. What are the ways that things are done? What is sort of agreed amongst all programmers how we do things? And one of the things is we try not to do things on one line. All right. So if I undo all that and I go back to what it looked like originally. All right. What some people also do, for instance, is let's say they want to create a variable. All right. Let's make it an int. Okay. And we call it age. Okay, and then they want to create another variable called money in bank. Okay, so let's say money in bank. Okay, so now they've declared two integers, age and money in bank. Okay, if you don't give an integer a starting value, like if I say equal naught, all right, then it'll assume with an integer it'll always be naught. It assumes you meant that. But just talking again about putting things in one line here, all right, that is not considered idiomatic. Okay, you shouldn't put things in one line like that. So you should rather break it up this way, and then that is more acceptable. All right, that's more idiomatic. All right, then if I undo all that, okay, then another thing that people can do, this is the indentation bit that I was referring to, is if you get rid of all indentation, okay? So we don't put things in one line, we just get rid of all indentation. Now, using something like Visual Studio, a good IDE, it'll normally look after indenting things automatically for you. It's not 100% accurate, but it's in most cases it works perfectly. Okay, so now there you're looking at the exact same program, but there's absolutely no indentation. So you don't really know what lies under what. Again, this is a fairly simple program, so you can figure it out in a matter of seconds. But I mean, if this function, the static void main function, didn't just contain the one line of code, console.writeLine, but maybe consisted of 50 lines of code, or 75 lines of code with if statements in it and so forth, with nested if statements and so on, it'll very quickly, you will not understand what's written there. So the fact that we keep things on new lines, all right, and we also follow indentation, makes our code reading that much easier. Okay, so that's just covering indentation. All right, the next thing, now we're going to have a look at what exactly are functions. Okay, so if we take this bit over here, highlight that, okay, that is a function. All right, static void main, it's got some arguments here, and then it writes out the word hello world. Okay, now what a function allows you to do is to take a piece of code, put it together, all right, and with a name, in other words, the name of your function, and call it whenever you want that code to run. Now what that allows you to do is, let's say you have a piece of code, all right, okay, well, one thing I must say, all right, in C#, a function cannot exist on its own. A function is always a member of a class, okay, so, but I'm not explaining classes to you at the moment, just functions. The principle remains the same as if classes didn't exist. Okay, like in certain other languages. But all right, so we have a function, okay, static void main. Now it is just an accepted, a lot of languages work this way, that the very first method that gets called by your program, in other words, the method that gets called by your operating system when it executes your program, when you double click on it or run it from a command line or whatever, it's got to start somewhere. And it's accepted that with C#, we always start with static void main if it's a command line application. And then, so what static says is it doesn't have to have, we'll go into details about this later, but static just says that an instance of class doesn't have to exist. You can call this directly. We'll get to that later. Not in this video, but we'll get to it when we get to object-oriented programming. All right, then you get the word void. So let's just take static out for a moment. Okay, let's pretend that doesn't exist. Okay, that is more what you'll typically see how a function is declared. So it'll say void. Now, what happens is a function can return a value. Let's say, for instance, you want to write a function that adds two values together, and the return of that function must be the answer. So when you say void, it means there is no return. Okay, void meaning like the dictionary term, the scientific term, there's nothing. All right. So if you wanted to return, for instance, a number, an integer, you would say int. All right. But then somewhere in your program, you've got to say return, like let's say number 12, okay, return an int, all right? So, but if you don't put that return in, it's going to complain, like it tells you there main. If we look at it, it says not all code paths return a value. That's correct, because it's expecting a return value. So if we go back to void, that means this function is never going to return anything, all right? Then after the function name, okay, it can be anything, but it's got to be named in Pascal case. So in other words, it starts with a capital M. All right. So let's say, for instance, the function's name was calculate two numbers. All right. the way you would name that function, for instance, is, well, firstly be descriptive, and then because it's a function, you have to use a Pascal case. So it is calculate two numbers. All right, so that's the casing, what it'll look like. Capital C, capital T, capital N. All right, that's how you'll name methods, or functions. Okay, that's the other thing about methods and functions. Okay, they basically refer to the same thing in most languages. People, grew up with one programming language, for instance, that called them methods, and then moved on to another one which calls them functions, but they're still used to calling them methods, so they call them methods. The opposite is true. Some people grew up with functions, and now they're working on something that calls it methods. But at the end of the day, for like most programming languages, they really they're the exact same thing. Okay, I'm, for instance, used to, in C# to refer to a function. I guess that's because of some of the other languages I work on as well that refers to them as functions. Okay, but so we've calculated. We've created a variable, a function that returns nothing. Now, obviously, if it says calculate two numbers, we expect, by the description, we expect a return value, but don't worry about that. All right, then after the calculate two numbers, I'm just going to rename it again to main. All right, you'll notice that we've got these two brackets, two braces there. All right, now with something inside it. All right, let's get rid of that to make it less complex. So what that's now is that's a function that takes no parameters and returns nothing. Okay, now parameters are things that are given to the function to do something with. All right, to do some function with. All right, some function on. So let's say, for instance, you're writing a function that adds two numbers. All right, so let's just take everything. Okay, we go back to, that is what the original program looked like. All right, so what we can do is we see that the under class. All right, so if I just drop that. All right, so we've got, well, if I drop everything, we start with the namespace. Inside the namespace is a class. Inside the class is a method. All right, and if you open the method up, you can actually see the lines there. All right, now you are allowed to, with methods, put them underneath each other and have, as many methods as you want that can call each other. So that's what we're going to do. So I'm going to create a new method, all right, which is going to add two numbers. Okay, now just because a method exists doesn't mean it's going to execute. All right, I'll show you now why. But okay, so because this method is going to be called from this method, from main, all right, which is a static. Okay, you'll understand why later. In your normal program, you're not going to have to worry about this, but you're going to have to name your new method as well by starting with the word static. All right, else they have difficulty in calling each other, and you have to create an instance of the class, and it gets technical. But so for now, we'll just say, so we'll do it the same. So it's static, and then we're going to call it add two numbers. All right, the return type can be, let's say we're only going to work with whole numbers. All right, so we know there's no decimal, no floating point numbers or anything like that. It can only be like a 1, a 10, or a -5, or whatever the case may be, but no floating point numbers. So that tells us, okay, the first question we ask, can this be a negative number? If the answer is yes, all right, just say int. Okay, that is a 32-bit number, all right, which can contain pluses and positive and negative numbers, including the number 0, of course. But you might say, no, this can only be positive numbers. Well, put a U in front of it, then it's uint. Now, the U stands for unsigned. Unsigned means there's no plus or minus, which means it's a plus. So the number is read as is. Now, with unsigned int, all right, you can store literally double the amount of numbers than what a normal int, which is signed, can store. But all right, so we're going to leave it on an int because we don't really know what numbers the user is going to give us. Okay, so all right, so we say the return type is that this function is going to do is it's going to give us an integer back, an int. The name is add two numbers, written in Pascal case, as it is idiomatic for C#. All right, then we're going to open and close our braces, and we're going to give him 2 parameters, okay, that he has to work on. So we're going to say, you know, be descriptive, but we're just going to call it param1, all right, and then also comma param2. Now what we want to do is we want to add those 2 things together, all right. The problem is it doesn't know what param1 and param2 is, okay. Well, they are also integers, okay. They don't have to be necessarily integers, but adding them together must result in the value of an integer, because that's what the method wants back. So we don't know, the guy might send us a negative number or a positive number. So let's say it's int as well, not uint. And then here in front of param2 we also type int. So you'll notice when we're declaring like functions, variables and so forth, the data type is always before the function or the variable name, okay. All right, and then in order to close our, or to create our function block, all right, we'll have 2 curly braces. And do that and press enter, and you'll see that C# went and put them on new lines for us and did the right thing, like we spoke about just now. All right, now the reason this is underlined here in red, okay, is it's telling us there's something wrong, all right. Now, I can tell you now what the problem is, but if you read it, it says, not all code paths return a value, which is true. So it's expecting an integer, it's expecting the code to return a value, but it's not, all right? So we have to return a value. So, well, you can just say, in order to return a value in C#, you've got to type the word return, all right? This is what you want to return, and then you have to return an integer. So if we make it, let's say number 1, 2, 8, all right? And then every line in C# is ended with, every command is ended with a semicolon, all right? Like C++ and so forth. And Rust and JavaScript, Java, they all work like that. Which makes it nice to move from one language to another. Sometimes, you know, it's nice and easy. All right, now, so this is all, everything is fine. If I had to compile this program now, in other words, do a test build on it, it'll say everything is fine, okay? But the truth of the matter is there's two problems here, okay? Firstly, we're not adding 2 numbers, we're just returning the value 128, okay? So this thing is not doing what it's supposed to be doing. So we need to add those 2, param1 and param2. So all you need to do is you can say return param1 plus param2. All right, because remember it's add 2 numbers. So we're adding param1 and param2. All right, you could, if it makes more sense to you, just put braces around that so you can just see easily. Okay, so that's what I'm actually doing, param1 and param2. All right, now that's a quick way of doing it. But you'll find as your functions start getting larger and so forth, you'd rather write something like this. So we're going to return something called answer. All right, we're going to create an integer called answer. All right, and in here we can immediately say equals param1 plus param2. All right, with a semicolon at the end. All right, so we've created an integer called answer. It contains the value of param1 plus param2, and then we're returning that answer. And now again, everything is fine, everything will work, it'll build and compile, everything is great, all right? The problem though is nothing ever calls this code, all right? So if we just run it, okay, it'll show us hello world, and that's it. But it's not going to add 2 numbers for us. So what we've done, there's our hello world, all right? So what we've done is we've created a function, all right, but we're not doing anything with it, okay? So let's go up to our first function that gets called when the program starts running. This is our main function, all right? So what we can do is we can, for instance, say, instead of saying console write line, we can write the answer, okay, of the adding of 2 numbers. All right, so we can change that, for instance, and say, let's write some text here, and we say the answer is, comma, and we'll say also, we'll just call it sum as the name of the variable, and then we'll create an integer called sum. All right, it initially is equal to 0. All right, so what we've done now is we've created another variable. Okay, the variable name is sum. Remember, the reason why it doesn't start in a capital, so it's not like that, like for instance the method is, it starts with a capital. This is a variable that we're dealing with now, and variables do not follow Pascal case, but rather Camelcase, which means that the first word starts with a lowercase. Like you might want to, if a better variable name here would be sum of two numbers. Okay, that's more descriptive, and it's following Camelcase. Okay, so everything starts with a capital O, but the words is the actual word starts with a lowercase s. That's the only difference between Camelcase and Pascal case, is the very first character. But the reason why in C#, it's splitting those two. It's all about understanding code, very quickly looking at it, and figuring out what the developer meant. Okay, so it's intent. What is the intent? And this helps in figuring out what intent is. The same as like using an integer instead of using a decimal or a byte is, it tells you his intent is that the result of, for instance, this function, his intent is that it can be a positive or negative integer. He's aware of that. If he made it, for instance, a uint, then his intent is that this thing should only calculate things where it's a positive answer, not a negative answer. All right, but if you go back up here now, all right, we're getting this problem, this underlying problem here now, this red line is because we changed the name of the variable. So just copy that. Okay, and we just copy paste it over that. All right, so now everything is good again. All right, so now we've created a variable called sum of two numbers, but we don't have the sum of two numbers yet. Okay, so there's two ways you can go here. All right, I'll first show you the faster way. It all depends on what your code does, readability, etc. Okay, everything is always a way up between readability, speed of execution, ease of understanding by other developers, etc. So, but this is a reasonably quick and simple one to do. So most developers will catch on to this immediately. So we can say, okay, so the int called sum of two numbers. Okay, so remember we've said it's an int. So what we want to do is change the value of sum of two numbers from naught to actually take the value of add two numbers, which is also an int. You see, they're both ints. All right. So instead of naught, we can say add two numbers. All right. Then we have to open our braces because we are now calling it. All right. And we've got to give them the first value. Param 1 is what value? I don't know, make up some number. Let's say 4. All right. And then comma, all right, and the next value, so 6, all right, close your parenthesis, all right, and that's it. So what's happened now is we've created a function, all right, we've given it a good name, very descriptive name, and all it does is it adds two parameters together, all right. Then, now, but we haven't called it. Then when we go back to our main method, this one is called by when the operating system runs the executable. So we know this one is going to execute. We don't have to do anything for it to execute except run the program, the executable. So what we've done now is we've created another variable called sum of two numbers, and we've made it equal the answer, the return value of the method called add two numbers. And the two numbers, param 1 is 4 and param 2 is 6. All right, so we expect it to have an answer of 10, and then it's going to write to the console, the answer is, and we say, print out the value of the variable which contains our answer. So it should print out 10. Okay, so if we say F5, all right, and there it is, the answer is 10. Okay, so we've called a function, and yeah, it's worked. It's run and everything is good. Okay, so the thing about a function now is we've separated some of our code from the main function. Okay, now this is something we'll cover a lot in the future. It's sometimes called, or not sometimes called, but it's called separation of concerns. Okay, so what that means is whatever module you're working with at the moment, like now currently we're working with a function. Okay, a function should do basically only one thing. All right, shouldn't really do more than one thing. Okay, so this little module, this add two numbers function, all it does is it adds two numbers. So we can call this function multiple times without having to rewrite this code every time. We just call add two numbers and we give it different. So let's say, okay, so add two numbers. All right. So the sum of two numbers is add two numbers, but we can change it again and we can say, okay, hang on a second, no. Okay, we want to create a new variable called int new answer equals, all right, we want to say again add two numbers, all right, but the first parameter, all right, is the value of our last addition. So in other words, sum of two numbers. All right, comma, let's say 5. All right, and remember, end with a semicolon. All right, now if we run this, we're still going to see the answer is 10. The reason is because we're printing out sum of two numbers up here, sum of two numbers. Okay, but so it's still 10, but we don't want to print out sum of two numbers anymore. We want to print out new answer. Okay, so if we replace sum of two numbers with new answer. Okay, so what's happening now is, let's just separate a little bit here. All right, so our first line of code is calling a function called add two numbers, and it's adding 4 and 6, which is 10, and it's storing it, in the answer, in our variable, because remember, it's returning it from the method. All right, it's returning the answer for us as an integer into the variable called sum of two numbers. But then in our next line, we're creating a new variable, also an integer, and we're calling the method again using the answer of the previous call, all right, this variable, and adding 5 to it. Okay, so in other words, our answer should now be 15. All right, so let's run it and let's see what we get. And there it is. The answer is 15. All right. And so you can do this multiple times. You've now got this method which you can call in a loop. All right. Well, let's do that. Okay. Since we've already learned about loops. Okay. Let's do something in a loop. All right. Like I said to you before, the most used loop is a for loop. All right. Typically. All right. So what we'll say is for, okay, sorry, my bad spelling there, open close braces. I know the braces are needed, so all right, and I'm going to say, okay, for int I, remember I did mention in my previous video, you shouldn't really call it I, but everyone knows what you mean. When it comes to a loop, if you say I, it is a variable name. We all know that I means, you know, it's an index or something. It's a counter of the loop. So we all know what I means. You don't have to give it a fancy name. Your boss might turn around and say you have to, but us programmers know when it comes to loops, I's are fine. All right. So just say for I, it comes down to intent, and programmers know what your intent is if you use I. So I, and we're going to have this loop run. Sorry, we've got to give it an initial value. We're going to have this loop run. Come on. We're going to have this loop run 10 times. Okay. So we say while I is smaller than 10. Okay, so that'll be, in other words, from 0 to smaller than 10 is 9. So from 0 to 9 is 10. All right. And I'm going to increment I by 1. All right. Then again, we've got to create the block for the for loop. All right. And okay, so what we need to do is, okay, so we're going to print out the, let's just call it answer. Okay, answer. All right. Or let's call it better, answer of loop. All right. So we need to declare a variable called answer of loop. All right. And it's, again, we know it's an integer, answer of loop. And we're going to start with the value of 0. All right. And then in our for loop, we are going to say, okay, answer of loop is equal to, equal to add two numbers. All right. Answer of loop, so the answer of the previous time that we did this, add two numbers, comma, and I. All right. So, okay. It's like, whoa, what are we doing now? Okay, it's actually quite simple. All right. We're calling, in fact, we can make this a bigger number. Let's make it 100. All right. So it's 0 to 99. So this loop will execute 100 times. Okay. And we only have one line of code in it. All right. Which actually does this bit of code. All right. Now, this could have been a very long function. In fact, it could be. All right, we can do some extra stuff in here. So give it some other name, do weird stuff to two numbers and write 50 lines of code that does some weird stuff to two numbers and kicks out an integer. But at the moment, we're just saying add. So what this loop is going to do now, all right, it's going to run 100 times from 0 to 99. All right. Remember I said previously that we typically count in programming from the value 0, not from the value 1. All right. So the first time it comes in, all right, the answer of loop, okay, was declared and was given a value of 0, all right. So the first time we come in, all right, we know that answer of loop is 0. So we're going to add two numbers, 0, comma, and then whatever the value of I is, our current value of I, as we're running through the loop. So it's going to be our counter, okay, or it is our counter. So it's going to start at 0, and then it's going to go to 1, 2, 3, 4, all the way up to 99. So what this thing actually is doing is going to take our previous answer of loop, all right, which initially is 0, because we set it to 0. This is the very first time we ran it. I is also 0, okay, so because we're starting at 0. So the answer of loop is going to be 0, comma 0, which is 0 plus 0, all right. So the first time we run it, it's going to be 0. All right. So you say, well, okay, nothing's changed. The answer of loop is still 0. That's correct. Nothing's changed. But remember, I gets incremented by 1. The moment we go around the loop the next time, remember, we've got to do it 99 times. So what happens the next time is, well, we know answer of loop is still 0, but I is now 1. Okay. So the actual answer of loop is 0 plus 1, so that's 1. Okay, so answer of loop is no longer 0 but 1. All right, and it saves it in memory. All right, because it's a variable, it saves it in memory. And so the next time that this thing comes through and runs again, all right, so it's now the third time. All right, so answer of loop is 1. So we're going to say add two numbers. Answer of loop is 1, comma, and in this case I is 2. We've already done 0 and 1. So it is 1, comma 2. So our result is going to be 3. And then we're going to start with 3 plus 4 is 7. And so this thing is just going to climb very fast. All right. So let's see what happens if we let it run for 100 times. What is going to be the answer of doing this little calculation on itself in a loop 99 times? So let's F5 it. And there's our answer, 4,950. Okay, so quite a big number. But all right, so that's showing you, how you can call a function with parameters and so forth and do something with it, and then recall that function. We've called it here 99 or 100 times. All right. So, but this is fairly a simple example, but there are cases where you might call even a function 1,000,000 times, and that it has got more than just one line and a return that actually does something. It might consist of 30 lines, which itself calls other functions. All right. But what I basically introduced to you here now is the concept of a function. All right. A function is a little module of code that you can recall and reuse multiple times whenever you need to. You normally don't write a function if you're only going to use it once. So let's say, for instance, if we undo all this, all right, and let's just say we want to, okay, we change this just to be, let's say, answer. All right, so we call int answer equals add two numbers 1, 2. All right, and that's in our entire program. All right, this is our entire program. all right? So it's going to kick out an answer for us when we run this. The answer is 3, because 1 plus 2 is 3, because we said 1 plus 2, parameter 1 plus parameter 2, or you can call, you know, first value, second value, you know, just be descriptive, all right, in your variable names, in your parameter names, okay? Very important. So it's going to be 3, but the thing is, it's kind of, all right, you've gone through this code to add these two numbers. And in this particular example, because literally we're doing nothing except adding two numbers, we don't really need to add a new function for that. I mean, seriously. You could have just said, okay, so 1 plus 2, okay? And you can get rid of this function. You don't need it, all right? It'll give you the same answer, 3, okay? But if it was a very complex function, for instance, okay, and you know, you don't want to mix up how simple your main should actually be. You want to call some function that does a lot of weird stuff, calls other functions and does all sorts of stuff and gets things out of a database, but ultimately comes back with a single answer, which is an integer. And okay, then fine. So you can then call, let's say your function is called do complex stuff. Oops. Okay, not a very descriptive name, but do complex stuff. All right, it's underlined because this function doesn't exist. It's just warning us. It's a nice thing about working in an IDE, integrated development environment. It can warn you about things like this. So without compiling and getting an error, you can immediately see there's some problem. But okay, let's say there's two values, 1, 2. All right, let's say it took 2 values. It might take something else completely. It might take an array as a parameter. You know, it might take, you know, a decimal as a parameter, or a boolean, or whatever the case. Any data type you can push in there. But that's the idea. So let's say, for instance, let's declare complex stuff. All right, so we go down here, and remember it's got to be static because our calling function is a static. If it wasn't a static, then it doesn't matter. Then you don't have to do. Then you don't do that. All right, but let's say, okay, so it returns an int. Do complex stuff returns an int. It takes 2 parameters. Let's say first parameter, okay, it's of type int, and comma, and then also of type int is second parameter. All right, and then we have to put in our curly braces. All right, and it now has to return a value. All right, and that value is the result of, for instance, yet another function, static. It's also an integer, and it's do more stuff. Do more stuff, okay? And it also takes 2 parameters, okay? And you can call them also, oops, sorry, should be capital P here. All right. I sometimes, if it's the same parameter which I'm passing from method to method to method, I keep the same name. But that might be the case in this particular function. But I'm going to be doing that. Let's say that's what I want my function to do. So it's going to be first parameter, okay. And in this case, it's not going to be second parameter that I'm passing through to it. I'm going to be passing some other value. Answer of some work. All right, and then what this thing must do is it must take those 2 values, all right, and do something. Okay, we're going to do it, say, a multiply. All right, so it's going to say return, okay, first parameter multiplied by answer of some work. All right, so it's going to return that. So that method, all right, that method, okay, we're just calling it do more stuff, not very descriptive, but all right, just to get the point across. It's going to take 2 parameters, first parameter and answer of some work. Then it's going to take first parameter and multiply it with answer of some work. All right, you could do all sorts of other stuff in here and call even more functions. But let's say this one now, for instance. So this one must also return a value. Now, it does not just do it's supposed to call do more stuff. So we get an int of, so let's just call it result, okay, equals do more stuff, do more stuff. All right, now do more stuff takes, remember, the first parameter, so we send it the first parameter, comma, and then answer of some work. You could literally make it R, all right, you can do whatever, but I like trying to keep the parameters the same as it flows through the different methods. So I'm going to say also it's answer of some work, all right, but now remember this is an integer, okay, end that line with a semicolon, okay. The reason why it's complaining at the moment is because I haven't declared this variable, all right. I declared it in this method, but not in this method, okay. It's got to do with something called scope. We're going to cover that now as well. All right, so answer of some work, all right, is, let's call it also an integer, all right, and answer of some work. I'm not typing very well today. Okay, answer of some work equals, all right, whatever you want to do. Let's say if, okay, I did show you a ternary a function that you can call when we were dealing with that in a previous video. So you might want to do a ternary call here and say, okay, we want to know if first parameter, okay, is an even number, okay, in other words divisible by 2 with no remainder, all right. You can go and write that as a method, all right. In other words, is, maybe call the method is equal. Maybe I should do that, all right. So we're going to say if some work, sorry, not if, okay, we're going to call a method that doesn't exist yet. It's going to return a boolean. It's called is even number, all right. It's going to take first parameter as a parameter, because that's what it wants to check if it's an even number. If it's an even number, remember this is how a ternary operation works, all right. So if it is an even number, then return the value, I don't know, let's just say, well, first parameter. If it's an even number, return first parameter, okay. So first parameter is even, return first parameter. But if it's not even, okay, this is how a ternary works, all right. So it first does a boolean evaluation. If the evaluation is true, it returns some value, which happens to be first parameter. It could be anything. You could, okay, whatever your use case calls for, your program calls for. But if it is not an even number, we just want to return the value naught. So in other words, we only want to deal with even numbers, all right. But remember now, even number does not work yet. So we've got to create that method. So we'll typically write it at the bottom here or wherever, but I'm going to put it up top here so we can see everything on the screen in one go. So it is static int. We know it's an integer. Is even number. It takes an integer as a parameter. And sorry, it's not an int, it's a bool. As a result, is even number must come back as a true or false. All right, if is even number, okay, create a new method here. Okay, now it's complaining because we're not returning anything. All right, the same as why this is complaining, we're not returning it yet. All right, the value yet. So is even number, then we're going to say, I don't know, very quickly. If, for instance, parameter. Come on, sorry, my mistake. If parameter divided by 2, okay. If parameter divided by 2, okay, so we need to do floating point conversion here. Okay, so we're going to convert this parameter, okay, to be a floating number. all right, because we're interested in knowing what the decimal result is if we divide it by 2. Let's say, for instance, the value was 3. Parameter is 3. If we divide it by 2, because we said it's an integer, all right, it's not going to work out for us what the remainder is. And that's what we're interested in. We want to know if the remainder, okay, is 0, all right. So we have to convert it to a decimal number, or what we call cast to a decimal number. All right, so I'm just going to cast it to, let's say, a single. All right, so capital S, single. All right, so if the value of parameter, which was, let's say, 3, casting it to a single changes to 3.0. all right, so it's now no longer an integer but a floating point number, single, and divided by 2. So if it's 3, we should get an answer of, you know, what is 3 divided by 2? All right, well, 1.5. So 0.5 is our answer. Sorry, 1.5 is our answer. But if we do that exact same calculation, all right, I'm just going to put it in braces just so we keep our things separate. Okay, if we say, if that calculation, all right, is equal to, all right, parameter divided by 2. All right, so it's still the integer. All right, so in other words, if there was a floating point number, all right, this calculation will lose the floating point part. 3 divided by 2 will just be 1, not 1.5. Whereas this one will keep it as 1.5. So it will say, does 1.5 equal 1? No, it doesn't. So therefore 3 is not an even number. If it was, let's say, 4 divided by 2, okay, it has no remainder. So 4 divided by 2 is 2.0, which is equal to 4 divided by 2 is an integer, which is 2. So 2.0 does equal 2. All right. So we're going to put this into a little... there's a nice quick way to do this, but so if we get in there, we're going to say, all right, return true. So that means it's an even number. Else we're going to say return false. All right, so this bit of the code here is even number. All right, it's going to look, is it even or not even? Okay, if it's an even number, then use first parameter. Okay, if it's not an even number, return 0. All right, so all our let's just make the code ever so slightly smaller. All right, so all our stuff is currently in use and returns something except to do complex stuff. All right, so it's not really doing anything yet. All right, but this result, okay, might be good enough to, in our, let's say, our programming requirement, we could now just say return result. Okay, so I haven't really defined a problem here for you, what program I'm writing. I'm just writing a program on the fly here that does something. What I'm trying to show you is how to use functions and how you can reuse functions, how parameters work and so forth, and we're going to be touching on scope soon. So if I run this program, it's going to come back now and give us the answer of this fancy program of ours. It says, well, the answer is naught. Okay, so me starting with 2 parameters of 1 and 2 does all these other weird and wonderful things, and it comes back and it says the answer is naught. Okay, so after all this, it comes up with naught. All right, so let's make this first parameter a bit bigger. Okay, let's make it 5,000. Just let's see what happens. All right, so it was naught the answer. So now it's going to go through all these functions and do all these comparisons of whether they're even or uneven. And here it comes back with the value of, what is that? That looks like 2.5 million. Yes, 2.5 million. All right, doing all these little functions of ours. Okay, now for interest's sake, all right, so I wrote this method here called isEvenNumber. You can use that now forever to see if something is an even number. Well, and obviously if it's not even, then it's an odd number, so you can use it for the same thing. Just look at what the result is, bool. If it's true, then you know it's even. If it's false, then you know it's uneven number. But with a ternary application, all right, we don't have to go through that. We can get rid of this entire method, all right. And so over here, it's now complaining that this method doesn't exist anymore. So using that ternary application, we can say, okay, first parameter, all right, and we use the percent sign, all right, 2. Okay, now, okay, so we just put this in brackets and say we want to make this do the same thing. Okay, equals 0. All right, so we've replaced that entire method now with just that little bit there. Oops, that. Okay, so the reason why this trick works is because of this little sign, this percent sign, the mod sign. I think it's called the modulus or something, but we just normally say mod. So it'll go and find out for us if it's like a division, all right, first parameter divided by 2, but what it does is it returns the remainder. So if let's say first parameter is 3 divided by 2 is 1.5, okay, this thing will actually return 0.5. All right, and 0.5 is not equal to 0. All right, so we know that this value is not an even number. If it was 4 mod 2, so in other words, we return the remainder, it's 0, and 0 equals 0. So therefore, it is true. So 4 is a even number. So if we run this now again, get the same answer. And there we go, we get 2.5 million. All right, so I'm just showing you in all languages actually. I can't think of another language right now that doesn't use the percent sign. All the languages I typically work with uses that. Some languages require you, for instance, to call something like math.mod or something, but this is called mod or modulus mod, and it'll turn for you the result of as if that was a division. Okay, so now I've shown you, all right, methods and how to call them. And why do you need a method is to keep a piece of code separate in a module of its own. You'll hear I mention modules a lot in my programming. I'm a big believer in following the idea of modular programming. That will lead you ultimately to like object-oriented programming and so forth. But a lot of things are modules, okay? So for instance, if you think like about modular programming, okay, in C#, well, a lot of languages have got this concept of a namespace, all right, but that is like a module, all right, so you can have 2 namespaces, all right, with 2 different names, all right, and they are then seen as 2 different modules. You can use the same variable names, the same function names inside them, because they are seen to exist in a different module. That namespace, the next one, let's say you call it 2, all right? You can have 2 modules. You can have 1 and you can have 2. So if you've got a copy of this code right underneath each other, but the namespaces are different, then it's as if everything inside of those namespaces are brand new inside that namespace. Even though you're using the same class name, function names, everything, it's allowed in a new namespace. So a namespace is a module, all right? Then inside this module, all right, we've got a class, all right? Now that comes to object-oriented programming. Don't worry about that yet. We're going to get to that soon enough though. But that class is also a module, all right? So things that happen inside that module, all right? You can have a different class called, this one is called class program. It could be called class bicycle, all right? And it might also have a main method. And that's fine, it can exist. But you know, if you can't with inside the same module, let's say I want to create another static, let's just copy this. Say I want to take this, make another method, okay, called the exact same name, all right, and it's complaining. And it says this program already, program already defines a member called main, all right? With the same parameters that we'll get to later. But so you can't have 2 objects with the same name, well, and the same parameters, but the same name, all right, in the same module, all right. So like I say, we've covered namespaces as being a concept of a module. A program itself is a module, all right. A DLL, a library, is a module. But so we've got a namespace which is a module you can think of. We've got a class which is a module. Classes are broken up into functions, all right? Each one of those functions can be thought of as a module. If you keep this idea of modular programming in your mind, you'll find it'll be much easier for you to break up your task, your program you have to write. You might get on a piece of paper, or somebody might tell you they require you to write the following, and then to actually approach it, how are you going to write it? One of the first things you do is you start breaking it up into modules and breaking it up into functions, etc. And data types and structures like loops and so forth. You break it down into these basic modules. So yes, okay. Now the last thing I want to touch on now is the idea of it relates to modules, but the idea of scoping, of scope. All right. So let's just make things simple again. Let's just get all the way back to our very original little Hello World program. Okay, so we're undoing everything. All right, and sure. Okay, covered a bit more than I thought we did. All right, there's our original program. All right, so let's say, for instance, I want to create a variable, all right, that's got my name in, all right. So it's a string, the data type, all right, and it's my name, all right, and it is equal to, I want to initialize it with a value immediately, and it is equal to D, all right. So put a space between those two, all right. And it's underlying name there because we're not doing anything with it. It's not an error. It's just saying, hey, you've never used it, so it's kind of a waste of time to create it. You're just wasting programming computer cycles, slowing your program down. But I could have then said hello, not hello world, but I could say hello and then my name. All right, and that will now kick out and say hello Dean. So if I run it, and there it is, it says hello Dean. Okay. Okay, but now what I'm getting at is, so let's say I want to have another, I want to say hello to somebody else as well. Okay, and they've also got a name, obviously. So let's say I want to say hello to my neighbor. Okay, let's say George. Okay, so he's also, it is a string. Okay, and I want to say his name is equal to George, and sorry, my mistake. George. All right, and now he's complaining. All right, why is he complaining about name here? He's saying, but name is a local variable or function name is already defined. Okay, a local variable or function named name is already defined in this scope. All right. Now your scope you can think of in this case between your braces there, your block. All right. You could though, if you had a different method. All right. Let's just call it static. Doesn't return anything. Just call it test function for now. Or let's say test scope. All right, doesn't take any variables. All right, and inside there, let's say for instance, I wanted to create a variable. All right, and I want to call it name. Okay, and this is whatever name I want. Let's just call it Stephen. All right, so okay. Now he's fine with that. He does underline it in green. They're telling us that we're not using it anyway. Okay, so I could also say this. Just put that there, and suddenly name will not be underlined anymore because now I'm using it. I'm just writing to the screen, hello Stephen. So this will write hello Dean, and this will write hello Stephen if test scope gets called. All right, so let's just call it. All right, so we say let's just call test scope. All right, no parameters, anything, we just call it. So now it's going to write hello Dean and hello Stephen. But the problem is, okay, we've got a string, a variable called name, all right, and in a different scope, in a different function, we also have a string called name, all right. and that's completely legal, all right, because it's in a different scope. Okay, scopes are important in all programming language and an important concept to understand. So the only way that I can have a second name here of George, all right, is to change the variable name. Okay, so we can say second name, all right, but it seems a little bit funny having okay, so you'll accept that now, but it seems a bit funny that we'll have name and second name. So it's better to keep the idea of how you name your variables the same, because everyone will understand better what you mean. So we change the first name to be first, the name to be first name, and second name to be second name. Okay, so now obviously we have a problem here because name no longer exists, and let's say I want to print out first name. Okay, first name. All right, so if I run this now, all right, we will have a hello first name, which is Dean, all right, and then after that we're calling the function called test scope, which is this one, and what it'll do is it'll say there's another variable with name. Okay, we can make this the same to show you first name. Okay, so we've got two first names now, but in different scopes, all right, different functions, all right. So we're going to have hello Dean and hello Stephen. So we say first name. Okay, and we run that. Okay, and then we've got hello Dean and hello Stephen. But now you ask me, okay, so where's George? Well, like it underlines it here, it says here to me, the variable second name is assigned, but its value is never used. So say, like, yeah, it's stupid. Why you're wasting space here? Like, what are you doing? Okay, you don't need this thing. You're never using it. All right. I could add it. Okay, I could say and oops, I want to use it and say second name. All right. So now it's going to say hello Dean and George, and then hello Stephen. And you see it's no longer underlined in green because I'm actually using it. I'm doing something with it. All right, so if I F5 on that, and there we have it. Hello Dean and George, and then hello Stephen. Okay, so you understand the concept of a scope. All right, things live in a separate scope. So we've covered indentation, and the reason why I chose indentation is just to explain to you, to write things in an idiomatic way, C# idiomatic way, where things are written on new lines. Okay, they're not all written next to each other in one line. It's just the Visual Studio IDE itself does make it happen for you. Sometimes when you press enter, it puts things on new lines for you and so forth, because it understands that that's how the language, what makes it idiomatic is to be on second lines or on new lines. But it doesn't always do a perfect job, but it's okay. But it doesn't like everything on one line. It likes breaking it up onto new lines, even though the code will work, but it makes it completely unreadable. And then the second thing is it likes having indentation. So you'll notice, like under that brace and that brace, everything is indented. All right, under that brace and that brace, everything inside it is indented. So you can very quickly see what lies under what is in what function, what is in what class, what is in what namespace. It's very easy to see thanks to indentation. Okay, and then we covered creating of functions and why you use functions. For code reuse, if you want to do the same bit of code over and over and over and over, or if it's a particularly complex piece of code that you want to extract from a method that you want to keep simple, and you just put that complex code in a different function and call it once from your simple method, then it doesn't clutter your eye when you're looking at the simple method. And you can obviously then go to the more complex function if you want to go look at what's happening inside there. And then we've also, like I say, we looked at modularity. Keep everything, try and think in a very modular way when you do your programming. And then finally we looked at scope. That's that you cannot use things with the same name in the same scope and so forth. There is one little caveat to it when it comes to variable names, to function names. You can have the same function name, all right, but then you must have different parameters, okay? But we'll get to that. So for now, just think of, you know, when you get to variable names and so forth, you cannot have the same name in the same scope. You have to change the name. Okay, and yeah, that's the basics of writing your program. And this brings us to the last step in this application. Like I said, this is a .NET Core application, which can run on Windows, Linux, Apple, your normal .NET framework applications, which is what Microsoft has been using since basically day one of, you know, the .NET. It's the programming language and frameworks and so forth. It was just called the .NET framework. Now they've got something called .NET Core framework or .NET Core. And Core, if you write your program using .NET Core instead of .NET framework, your application can run, like I say, on multiple platforms. This is becoming more important in today's life. You know, not everyone wants to run something on a Windows machine because it's expensive to buy a Windows machine. You just get a developer to write you something in .NET Core. You have a free Linux server running somewhere, and this application of these can run on your server and do what you want it to do, how it's been programmed. But all right, so let's say we get to the final step now, and we actually want to have this executable run, for instance, on Windows or Linux or wherever. So let's say we're going to run it. We're going to compile it first for, well, let's say Windows. Okay. So like if I press F5 now and I run it here, this is not really. It creates the exe and runs the exe for you. Okay. But it's not necessarily optimized in any way or whatever. We can get to that at some point. You can make it, you know, optimize it for 64-bit operating systems and so forth. But okay, so you'll go to on the right here. The first thing you'll see is there's a solution, all right, and under that is your project. A solution always consists of at least one project, all right. So if we right mouse click on the project name, okay, we'll see here something called publish, all right. Choose publish, okay, and it's going to come up here and now ask us, okay, where are you publishing to, all right. I'm just going to publish it to a folder. In other words, to the drive itself. All right. So you go to next. All right, and then it asks you the path where it wants to publish it to. Okay, it's relative to your project's actual path. You'll notice there's no C:\/ or whatever in front of it. So that means it's relative to your current path that you're working in. So we'll leave it on that. That's fine. Okay. And say finish on that. Okay, then when we get to this point, it's going to ask us, all right, the configuration, all right, we're going to leave that on release. You get debug mode and release mode. Release mode is typically the one that when you actually finally release your product onto the server into a live environment, you know, where people are going to start using it for real and so forth. You want to leave it on release because it runs much faster. But if you're still, you know, what we call debugging it, trying to find little mistakes and whatever and so on, we sometimes don't release it, use release, but debug. But in your case, if this is your final build and you want to put it on a server, then it's in release mode. Okay, your target runtime. Okay, this is the important one. So it's portable. All right. So we can say here, release any CPU. You can specify, for instance, the framework. Okay, yes, .NET Core is the only one that's on here. Deployment mode is framework dependent or self-contained. Okay, this is an important one. All right. The thing is, it's the same as with the .NET framework, which is a little bit different to things like Rust and C and so forth, is that you can't just build an executable and give somebody that executable and expect it to run on their computer, even though it's a Windows computer. You wrote it on Windows, you give it to someone with Windows. Okay, they have to have something installed called either the .NET framework or the .NET Core framework. Okay, now since we're using .NET Core, okay, it's telling us that I can only do a .NET Core 3.1 app, all right? I don't have other versions of .NET Core installed on this computer. So it tells me my target framework is .NET Core, okay, 3.1, which is good, all right? And the target runtime, and this is where, sorry, the target deployment mode, all right, is where it comes in. If that person on the other computer that you're giving this executable to, if they've installed the .NET Core framework, okay, version 3.1, okay, on their system, all right, then you can just leave it on framework dependent, okay, because when you run the executable, it'll query the .NET framework that's already installed on that computer and start using the libraries as it needs it and so forth. So that normally gives you a very small amount of data, like it's basically just the executable file that you run on that computer, the computer that you're deploying it to. But sometimes that person does not have the .NET framework, or for instance, maybe you're deploying to Linux, all right, and they did not install the .NET Core framework on Linux. But so they do give you an option here to say self-contained. And what that does is it takes all the .NET Core libraries that it needs to execute and puts them into the folder with your exe file. So when you run your exe file, your executable file, it knows where to find those libraries for the .NET Core framework. Because it doesn't stick like with C and so forth. They stick everything into one executable. Okay, .NET framework doesn't work that way. It requires the .NET Core framework to be installed. All right, and then it calls it as it needs it. So it doesn't stick it all into a single executable. Because I mean, the executable will be massive because the .NET Core framework is so big. All right, so I've said, okay, let's assume that the .NET Core framework is not installed on our friend's machine, the one we don't want to give this executable to. So we say self-contained. So it'll stick all the requirements into one folder for us. All right. And then it's saying, okay, and what target are we going to run on? What target runtime? This is Win-x86. So this is a Windows machine that we want to target. But you can also, let's say, for instance, we go to 64-bit Linux. All right, you click on Linux. All right, and that's this application now can't run in Windows. It can run in Linux, but it's the same source code. It's the same C# code you've written. Okay, but let's just for interest sake, let's change it and let's run it on Win-x86. And we're going to say framework dependent. So it's going to be the smallest file size, the smallest directory contents that we can have. Of course, we know that our friend has got the framework on there, installed on their computer already. And we know that it's a Windows machine that they're running. So let's save that. Okay. And if we press publish, it'll go ahead and create that folder for us. It's going to contain the exe, which we can give our friend. All right, so it's saying publishing. It's running through it all for us. Okay, publish succeeded. All right, so it's done it. Okay, so what we can go and do is we can go to that folder that is being deployed to. Now, like I say, I'm going to show you that if it's a relative folder. All right, so if I right mouse click on my project here and I go to open folder in File Explorer, all right, we should find that we have a folder called bin release. Okay, so we've got, according to okay, so according to here, we have our folder is bin release.NET Core app 3.1 publish. So we go to bin, all right, release .NET Core app 3.1 and then publish. Okay, and there is the requirements. Okay, that this is what we need to give our friend if he wants to run our application. Okay, you don't need to give him all of this, but okay, you got to give him the exe. I'm not sure you need to give him the DLL, and none of the others really matter, but I think you only need to give him the exe. Okay, so that's 135K in size. So that's what you're basically giving him, is something that small. All right. So let's leave this window open, but let's change it and say, okay, we want to still go to Windows, all right, but our friend does not have the framework installed, all right. So we're going to do a self-contained. So in other words, we're going to install the .NET Core framework, not install, but copy the .NET framework across as well. And we save that and we say publish. All right. And if we come look at our folder, we'll see what happens when it's finished. Okay, so it was basically just a 135K file we had to give our friend. All right. Because we know that they had the .NET Core framework installed on their computer. You know, most Windows machines, when they come out, they already have all these things, especially the .NET framework. Not necessarily the latest version, but reasonably close to the latest version. And it gets updated frequently as you do Windows updates and so forth. And that will be happening with the .NET Core framework now. .NET Core framework as well. So you can be reasonably sure your friend's got .NET Core. Okay, it's still determining projects to restore here. It's taking a while. Okay, and it is succeeded. It is complete. And wow, how many more files do we now have? All right, that's a whole lot of the .NET Core framework libraries that are included. And if you remember, my program, or this program, starts with my first application. So it's still only 135K in size, all right? But you have to include all these other files when you want your friend to run your program. Okay, but so it's good and bad in the sense of it's bad in the sense it's giving you all these extra files just to run your simple exe file. But that does allow the fact that your friend doesn't need to have the .NET framework or the .NET Core installed on their computer, or your particular version that you wrote your program in. They might have an old version or a newer version. You might, for a very specific reason, require an old version of .NET Core. Then you can say, okay, don't use the one that he's installed. Use the one that I'm giving you now in the same folder as the exe file. All right, then as a last thing, what I'm going to do is show you that this is only, you can only do this with the .NET Core, not with the .NET framework. Okay, so the last one is if we go look at the target framework, all right, and we're going to change this target framework from Win86. We want it to run on 64-bit Linux, all right. So in other words, on Ubuntu, on CentOS, any modern Debian, any 64-bit version of Linux that does not have the .NET Core framework installed. All right. So say it's still self-contained. All right. So we'll save that and we'll publish this. Okay. So remember now it's still .NET Core API 3.1. It's going to Linux x64. So in other words, 64-bit Linux. We're going to then, once this is compiled and built up, we're going to then copy this over to my Linux machine, which I'm currently working on. And let's see if it runs. Now, I do have .NET Core 2.1 or something on that Linux box. So, okay, the publish has succeeded. But now, obviously, we want .NET Core 3.1, which is not installed on that machine. So that's why we had to include the entire framework. It's what do they call it? A self-contained, the self-contained deployment mode. So if we go and look again at the files, all right. So this is where the window files were. So it's Win x86. So if we go one back, .NET Core 3.1, and we go to the Linux x64, that's the one he's just created now. Okay, so here are all those files. And there's my first application. Now, it's not a .exe because Linux doesn't work with .exes, but we just call this a binary. Okay, so it's 89K in size, but it still comes with the entire .NET framework, .NET Core framework behind it. So let's copy that over onto my Linux box and let's see what happens. So the first thing we'll need to do is open FileZilla, so we can FTP across. I suppose you could SSH, but we're going to try and keep this Windows oriented, so we're doing FTP. Okay, and just connect to my machine, and that will be Alright, it's trying to connect to my machine, the Linux machine that I'm on at the moment. Remember, this whole video is done in a virtual machine. So the actual host machine is a Linux machine. Alright, so if we come onto this side, let's just find that path to where it's lying. So if we just take that path, source repos, decommon source repos. All right, I wonder if we can just copy this path. Looks like we can. There we go. All right, so there's line x64. So here are all our files that we just created in Visual Studio, .NET Core for Linux. All right, and this is our Linux machine. So let's just create a folder on here, for instance, in the home here. I don't know, let's just call it .NET, just core, okay? Create a directory, and we'll call it core, okay? Oops. I think my spelling was a bit messed up there. Where we are, core. Just correct that, C lowercase. All right, so core. Okay, so we go into that folder. We come over to the Linux files lying on the Windows machine, and we copy them all over onto Linux. All right, it's busy copying over, and okay, let's just let that finish. All right, and all the files are copied over onto Linux. So if we have to now minimize this virtual machine, all right, go out of full screen, okay, and let's minimize it. All right, so we're in Linux now. So if we go to home, we should have a core folder here. Where it's still loading it. Okay, there's a core folder. So this is where we just copied it to. Okay. So there's all the files we just copied, all right? So what we want to do is execute it, all right? So we'll say open in terminal, run it from the command line, same as we did in Windows, okay? And just for interest's sake, let's just say .NET -- version, all right? Okay, so it tells me that my local version of .NET installed in Linux is version 2.2. Okay, but remember, this is a .3.1 application that we're trying to run now. So do that. So then it is my first application. Okay. Oh, sorry, .dll. Yeah, that's the one you must run. You must run the .dll. Okay, and there we have it. Hello Dean and George, and hello Stephen. So even though it's .NET version 2.2 installed in Linux, because we've made it a self-contained folder with .NET Core libraries in it, it's actually just executed a .NET Core 3.1 version of an application, not the default installed 2.2 version of the framework. So that's actually very good news. So you don't need to install the entire .NET framework, .NET Core framework on Linux. Just make it a self-contained folder, and there you go. All right, so if we go back to Windows, and where's my Windows? Here we go to Windows, and just make that full screen again. All right, and okay, so we're back in Windows, and okay, so all right, one important thing we must just note is we now did a what .NET Core does for us is we can run our Windows on 3 major systems, and I think ARM as well, but Linux and Windows and Apple, and with the same source code, the same C# source code. So you write your program once. Look, I'm sure there'll be minor little things that when you start interacting maybe with the operating system directly, but in general, your C# code will have the exact same code base on Linux and Windows, etc. If you're using .NET Core. That's the beauty of .NET Core. Don't get it confused with another technology from Microsoft, which allows for multi-mobile platform development, called Xamarin. That allows you to write mobile apps for Android and Apple and Windows and so forth. It's not the exact same technology. Two different things. This is more for servers and desktops, .NET Core, and then Xamarin is for mobile applications. So, well, great guys. So we've done quite a bit of work so far already, and I think we're now ready to start jumping into the real nitty-gritties of writing C# programs. In other words, we've got to get to know object-oriented programming and so forth. And I think, yeah, that's what we're going to get into next. So enjoy it, and as per usual, I'll see you next time. Thanks, man. Bye-bye.